Great. So now we will move into our judged competitions. And again, applause is encouraged after each presenter. We'll then give a little bit of a pause for the judges to make their comments and then invite the next presenter to the stage. So our first presenter tonight is going to be Nitish Ponkshe, and the title of his talk is Morphing Head of an Underground Burrowing Robot. Nitish.
Good. As a kid, I remember watching on TV the tense rescue operation of Prince, a 6-year-old boy from rural India who fell into a 55-feet bore well. Bore wells, dug for the purpose of pumping groundwater, have extremely narrow openings. A horizontal hole had to be dug from a nearby well. It took more than 48 hours to reach him. Prince was lucky to survive, but most victims are not. Every minute matters. The Mechanical Energy and Power Systems Lab at the University of Minnesota is building an earthworm-inspired burrowing robot that can form tunnels underground by navigating around rocks instead of drilling through them, saving time and energy. The robot compresses the soil instead of removing soil like drilling systems. I am designing the apex portion, the head of this robot, that leads the robot underground. Most existing burrowing robots use a fixed conical head where the head merges with the robot body. We have built a novel two-step morphing head that can actively change its shape. In the first step, the push step, the head makes a tiny indentation into the ground. In the second step, the expansion step, the head expands and enlarges the hole, creating space for the trailing robot body. The tiny morphing head has very little friction compared to the large conical head. Think about pushing a small needle in the ground versus a large steel rod. Only this time, the needle can balloon out. Our computer code has shown 30% savings in energy when using a morphing head that has half the diameter of the robot body as compared to a fixed conical head. Next question, how do you build this morphing head? The morphing head is just like an umbrella. It has stiff metal links wrapped inside a soft polymer. During the push step, the metal links are stiff, like a closed umbrella, and expand during the expansion step, like an open umbrella. It is imperative to discover minerals and groundwater reserves for our survival. Conventional drilling methods may cause significant damage to the environment. Our burrowing robot can alleviate these issues, exploring the unexplored depths of the earth, being highly energy efficient and fast. Thank you and have a good evening.